One of the most significant changes in human biology over the past century has been the lifetime exposure to menstruation. Most women who live to the age of 52 have experienced more than 400 menstrual cycles, in contrast to 250 in the 1900s and 100 back in the 1840s. This is a result of an earlier start of the first period, a later age at menopause, a longer life expectancy, and a lower frequency of pregnancy. Yet, we still don't understand why menstruation has evolved. Menstruation is only known to occur in 4 other species: higher primates, some bats, the spiny mouse, and the elephant shrew. Why do these mammals menstruate while most do not? What is the evolutionary benefit, if any, of menstruation? Welcome to the Reproductive Health series, a School of Women's Health production. On this channel, we dive into the research on women's health, aiming to decrease the gender gap in research and medicine and empower women. This is episode 1 in the Reproductive Health series. Research still hasn't found a conclusive answer, and experimental research on this topic is lacking, but many hypotheses have been put forth. In this video, we will focus on the most widely accepted hypothesis, known as the conflict hypothesis. What is the difference between mammals that menstruate versus mammals that don't? It all boils down to the placenta. There is a large variation in invasiveness of the placenta. 3 different types can be identified in mammals. At the top, there's a blood vessel depicted belonging to the embryo. Right underneath, in yellow, you can see embryonic cells that form the placenta. Attached to the placenta, we find blue cells that are part of the woman's uterus, with a blood vessel belonging to the woman right below it. In the center, red blood cells can be seen. With this placenta type, the cells of the woman's uterus form a direct barrier between the placenta and the woman's bloodstream. The placenta is confined behind a barrier of blue cells. This barrier lets the woman control the supply of nutrients to the embryo. In the middle, we see that the blue cells belonging to the woman's uterus are no longer visible. The embryo has increased its invasiveness. We can also see that the woman's blood vessel wall is still intact, meaning that the embryo does not have direct access to the woman's bloodstream. Finally, on the right, we find the most invasive type. Here we see that the placenta now has direct access to the woman's bloodstream. The blood vessel wall is opened up. The most invasive variant is only found in menstruating species, and thereby holds an important clue. Increased invasiveness of the placenta benefits the embryo, allowing it to extract more nutrients, but it puts the woman at risk. If the embryo develops poorly or dies, the woman's health is endangered, since toxins will be released directly into her bloodstream. This is of particular importance in humans, with an exceptionally high rate of impaired embryos. Therefore, nature has had to find a way to deal with this increased invasiveness of the embryo. So, how did nature respond? Menstruation is believed to be a consequence of the adaptation that evolved, the spontaneous desidualization reaction. Desidualization takes place in the tissue that lines your uterus, the endometrium. The purpose of desidualization is to prepare the uterus for pregnancy. In humans, this is exactly what happens during your menstrual cycle. It's the monthly buildup and consequent breakdown of the endometrium. During menstruation, the endometrium, which has grown about a centimeter, is shed. Then, during the follicular phase, the endometrium is rebuilt in preparation for the release and potential fertilization of the egg. Desidualization is present among both the menstruating and non-menstruating species. The difference lies in when desidualization occurs. In non-menstruating species, this process only occurs when an egg has been fertilized. It's the embryo that triggers desidualization. In menstruating species, this process happens spontaneously. The mother has gained control over this process. Why was spontaneous desidualization necessary? Why does it need to occur on a monthly basis? Why can it only happen when an egg has been fertilized? 2 possible selective forces may have been at play. The first selective force could be the increased invasiveness of the embryo. Since the spontaneous desidualization reaction starts before an egg has been fertilized, it probably provides earlier and more effective protection in case of fertilization, which is needed with an embryo that is much more invasive. The second selective force could be the high incidence of impaired embryos. Us humans have an exceptionally high rate of chromosome abnormalities in our embryos, which makes an unsuccessful pregnancy much more likely. Most non-menstruating mammals are able to expel or reabsorb impaired embryos. In humans, this is not possible because the endometrium has become thicker as a result of the increased invasiveness of the embryo. The only way for us to remove an impaired embryo is through menstruation, since during menstruation, the outer lining of the uterus is expelled. Menstruation is therefore of vital importance in protecting the mother. After all, if an embryo is not of good quality and dies, it could potentially release toxins directly into the woman's bloodstream, which would endanger her health. Although both of these explanations for the evolutionary benefit of menstruation require further testing, it's fairly clear that a conflict of interest between the embryo and the mother has driven the evolution of menstruation. Women have had to adapt to the increased invasiveness of the embryo. Since the embryo and mother have different goals, the embryo wants to grow and obtain as many nutrients as possible, whereas the mother wants to protect her health and secure the success of this and of future pregnancies. There are different interests at stake, resulting in an evolutionary tug of war. Thank you very much for watching this video. I hope you found it informative. If you're left with any questions, please feel free to leave them in the comment section below and I'll try to get back to them. I've also linked a couple of relevant research articles in the description box. Stay tuned for next week's video on how ADHD differs in women.